Okay, here we go with problem number 20. We have the graph of f prime given to us. Let f be this function with the continuous derivative f prime shown above. So there's no jumps or holes or anything like that in this graph. Find all the values of x on the open interval from -6 to 3 where the graph of f has a horizontal tangent. Okay, so that means that f prime will be equal to 0. So the graph of f prime is equal to 0 here and here. It's the open interval, so we don't count this one because we don't see the less than or equal sign there. Okay, so we have x equals -2 and x equals 2. All right, that was the first sentence. Second sentence, determine whether f has a local max, local min, or neither at each of these values and justify your answers. Right, in other words, give a reason. So let's talk about -2 first. Here's the graph of the derivative. In order for this to be a max, we need to see a change from positive to negative. We don't. We don't see a sign change at all. The graph of the derivative is positive before and after -2, which means that we have neither. And we have to justify the answer, so we're going to say because f prime does not change sign. Then we get to x equals 2. Well, now we see a derivative which is positive and then negative. A positive and then negative produces a relative or local max. All right, so we can say local max. If you write relative max, that's 100% correct. It's okay. You can use either adjective. So local max, because f prime changes from positive to negative. You must have the reasons. If you just write these numbers right here, they will not give you any credit. Find all values of x for part B on the open interval for which the graph of f has a point of inflection. All right, so a point of inflection is where the first derivative will change from increasing to decreasing or vice versa. Since we have to explain our reasoning, why don't we write that down right now? So I'm going to write because, all right, f prime changes from, be careful here, we're not doing positive to negative. All right, we need to see increasing to decreasing or decreasing to increasing. All right, so let's find that. Where does the derivative change from increasing to decreasing or vice versa? Let me get the graph back on the screen. Our derivative is increasing and then decreasing. There's one spot. Decreasing and then increasing. There's another spot. Increasing, then decreasing. There's a third spot. Decreasing continues to decrease. So we have 3 spots where our first derivative changed from increasing to decreasing or vice versa. They happen at x equals -4, x equals -2, and x equals 0. And again, the reason is already written.